le slide. Alors, importer. Charger. Un PDF.
Comme ça, à la limite, nous, on les met en favori. Si jamais il y a un souci, on peut intervenir dessus et le remettre.
Ouais. Alors, présentation américaine. Et elle fait... Ah, elle fait 2,3 mégas, ça va?
Oh, ça va.
Ça va le faire? Bon, allez, je vais la charger sur l'écran. Alors, est-ce qu'on entend la personne qui parle aussi à côté de moi?
Là, on n'entend rien.
Oui.
Un petit peu.
Et moi, je l'entends un peu. Ouais.
Tu l'entends, Nico?
Ouais. Là, non.
Quand on va être deux à parler à 10h. Alors, télécharger le fichier à l'écran.
Alors, c'est bon à savoir ça parce que nous, justement, on est là aussi pour intervenir si jamais des gens oublient de couper leur micro pendant la présentation.
Ouais.
C'est bon à savoir si jamais il y a un bruit de fond, c'est pas forcément quelqu'un de la salle, quoi.
Non, c'est ça, parce que là, on est les deux pas loin de l'autre. Et donc là où je suis en train de parler pour essayer, pour voir si l'autre entend. Et voilà, est-ce que vous entendez l'autre
Ouais,
présentateur aussi?
on a entendu. Ouais. Bon, enfin, moi, j'ai entendu.
Un petit peu, quoi.
Un tout petit
Oui,
peu, mais vraiment léger, hein, c'est pas...
D'accord. Bon, il est en train de télécharger le
En tout cas, vous, le son,
truc.
il est nickel. Hein.
Ok,
Ça,
j'ai un casque, là, donc
c'est bon.
ça charge, hein, doucement.
Ouais, pas de problème.
D'ailleurs, Ben, on m'entend bien, moi, parce que tout à l'heure,
Ouais, Nico, on t'entend bien.
Ouais, d'accord.
Ouais.
On t'entend bien.
Converting. Et après, quand tu le mets en favori, en fait, il reste enregistré, quoi, quelque part?
Ouais,
c'est ça.
c'est ça.
Reste, ouais.
Voilà.
Ouais, bon. Il n'y a personne qui a lancé la diffusion encore au Laval Virtual Center, donc, enfin pour Laval Virtual Center, à l'espace Mayenne. Vous savez qui doit la lancer normalement?
C'est Laval, je crois.
Mais qui précisément, quoi?
Ah, je sais pas. Je sais pas. Nous, les captas commencent ça. En fait, normalement, les captas, ouais, ça commence à 9h dans les captas. C'est qui? C'est Léo.
Léo?
Ouais.
Où? Oh? Bon, super. Ariette m'a dit qu'on m'entendait dans la salle Convergence. Super. Eh bien, bonjour à tous, la salle Convergence. Je ne vous vois pas, mais vous me voyez. C'est génial. C'est génial. Alors, ça charge. Ah, ça y est, ça a chargé. Vous le voyez sur l'écran, là?
Ouais. Ok, là, c'est le PDF, là, du coup?
Ouais, là, c'est le PDF. Alors, attends, je
Ok,
vais essayer.
super.
Alors, donc, moi, je
C'est bon,
passe avec.
moi, c'est enregistré, du coup, au cas où.
Ouais,
Attends, je vais mettre pareil en favori. Clac. Et alors, attends, est-ce que je peux changer de slide? Ah, si, ça change.
Moi, je peux, ouais.
Attends, c'est toi qui l'as changé ou c'est moi?
Oui, oui. Là, c'est vous, ouais. Ouais, on peut se tutoyer, ouais, pas de souci.
Voilà, attends, pourquoi je suis tombé sur le. Waouh, je suis tombé sur Google maintenant.
Ah.
Attends, bon, attends, je regarde si c'est moi qui. Là, je bouge avec les flèches. Donc, le programme. Tac, welcome. Ah, pourquoi il va là-dessus, lui? Eh, c'est quoi ça? Il est repassé sur le site web maintenant.
Alors, remettez-le.
Attends, hop, je vais remettre sur le.
Ouais.
Vince. Attends, là, je reviens sur mon
Ok, c'est
truc.
bon, ouais, c'est bon.
Alors, taille 2. Eh, parce que si tout le monde, s'il y en a qui cliquent.
Ouais, c'est ça. Ok, c'est bon.
Attends,
Non, c'est bon.
faut que je clique dessus en fait. Comme, clap your hand. Ok, voilà, ça commence. Pokémon. L'intelligence, Laval Virtual Center, Better Understanding, Create. Welcome to a new world. A few tips, good practice. Alors vous entendez derrière moi l'autre qui parle, c'est ça aussi? Présentateur, j'imagine.
Ouais.
Pas trop gênant ou pas? C'est un peu.
Non.
Bon, ça va.
Tu l'as enregistré, Nicolas?
Oui, oui. Bah, je vais voir si je peux le
Ouais, vas-y, fais-le.
changer.
Ah oui, là, tu l'as remis au début. C'est
Voilà.
ça?
Ouais,
Ok.
ça revient au début par défaut, ouais.
Moi, par contre, bizarrement, ça marche pas. Alors, attends.
Là,
Ok.
c'est moi qui les change. Hein. En fait, non, vaut mieux cliquer sur l'écran pour les changer. Ça évite de partager mon écran.
Là, tu l'as mis en favori, Ben?
Bah, je sais pas, ça me le met pas. Hein. Ça me le
Ah
met
bon?
pas. Ouais. J'ai pas de lien, quoi. C'est bizarre. T'as bien
Alors,
cliqué
tu
sur
as...
la petite étoile?
Oui, oui, mais tu es dans l'outil de présentation, là, c'est ça?
Ouais, ouais, ouais.
Ah,
Alors,
c'est
attends,
bizarre,
je le
ça.
fais de moi. Je le fais de mon côté. Peut-être que.
Oula.
Mrs. Long,
Yes?
we found a baby girl for your adoption.
Ben,
C'est moi
She's
qui ai mis
in
une vidéo.
Siberia,
Hein.
and she was born with a rare
Bah, moi, je sais pas,
condition.
ça le lance pas.
Her legs will need to be amputated.
Ça le lance pas sur l'écran.
Présentation.
Alors,
Ah,
attends,
voilà,
je vais le réessayer. Ah, parce qu'au moment où. Ok, d'accord.
Pourquoi ça? Ah oui, non, t'as enregistré mon.
Ouais,
Ça,
c'est
c'est
ça, ok,
c'est un
d'accord.
truc que je
Je me
viens
disais
d'effacer en
aussi.
fait.
Ok, alors, remets
Ah, attends, je vais le
le
remettre
tac,
alors.
ouais.
Attends, je le remets.
Je me disais aussi, c'est bizarre, ça.
Enfin, s'il veut,
moi, je
prenne
peux
ma
le
main
faire,
peut-être.
sinon.
Alors, prenez possession. Je prends possession. Et alors, regardez. Allez, il peut revenir. Et qu'est-ce qu'il fait? Attends, là, il y a Google. J'enlève Google. Ah, voilà. Donc là, il est
Ok,
revenu, hein, c'est ça?
alors attends.
Alors, vas-y, mets-le en. Ah,
Ok,
Geoffrey, tu
alors
es là?
attends. Ok, c'est bon.
Je vois Geoffrey quelque part, je ne l'entends pas.
Par contre, là, alors attends. Oh.
Putain, chouette.
Attends, Nico, j'arrive. Ok, c'est bon. Là, je le lance.
Bonjour, caméra 6. Bonjour,
C'est bon.
caméra 5. Fais un petit échauffement.
C'est bon
Ouais,
pour moi, Nico.
ça marche. Bon, bah, Simon, on va retourner à la réception et on revient bah, quand ça commence, dans pas longtemps.
Ok, ça marche.
À tout à l'heure.
À tout à l'heure.
Tout à l'heure.
Oui, Simon? Je- Simon, c'est
Ouais,
Nicolas?
tu m'entends?
Oui.
Ouais.
La conférence va commencer. Du coup, est-ce que tu connais le nom de l'animateur qui est en support? Parce qu'on ne connaît pas, nous.
Bah, t'as Olivier Chrisman et Geoffrey Goris. Il y a Geoffrey qui est connecté, mais je sais pas où ils sont.
Alors, ok. D'accord. Bon, ça commence à arriver, hein. Je me mets sur le côté, du coup.
Je vais aller voir s'il y a du monde dans la vraie salle.
En fait, c'est un problème de micro.
On
On
entend
m'entend
là
après?
Oui, on
Ouais,
est
je
dans
t'entends.
un...
En fait, c'est quoi, j'ai vu, c'est pas sur le micro en bas à gauche.
On vous entend, Olivier et
Oui,
Geoffrey. Bonjour.
on s'était.
Trop classe.
Hi, Anthony.
Hi, Trevor. Hi. Can you hear me?
Yeah, I can hear you. I was just trying to work out which button is the mic. Am I in the right place for the talk?
Yes, I think so.
Yes. Hello, Anthony. Welcome.
Oh, hello, Simon.
Yes, it's the right place. We're going to introduce the session in a few minutes.
Okay. All right. Where are you now, Trevor?
I'm working in Stuttgart, and I'm a project leader in multi-user virtual reality.
Ah, very good. Is that DFD still? No.
No, it's in industry, so it's virtual reality for prototyping and simulation.
Oh, right. Okay. Great. What platform are you using?
So it's basically in-house stuff, our own software application.
Right.
Surprising, I know.
Yeah. I mean, there's so many people building tools that.
Yeah.
Yeah. I've talked to so many startups in London that have been doing, product review or tools for, because for industry, because that's what they think will sell, and trying to persuade them that what they need to do is build them for very specific clients. It's almost one per client.
Sorry to interrupt. Hi, both of you. Please remain mute. The conference will start in a few seconds. So if you want to discuss, please use the private chat, if you don't mind. Thank you. Du coup, Simon, c'est vous qui décidez. Hein.
Ouais, pas de problème. Okay, I think we're going to start. Then welcome to everybody. We are very glad to welcome you. It's a strange organization this year because we are in Comodan mode, because I am in Espace Mayenne, the brand new place in Laval, where stands the exhibition, Laval Virtual, real physical exhibition and small exhibition. This year we are a little bit more than 100 exhibitors instead of 300 usually. And so I'm now in a small room in the Espace Mayenne, and another speaker is speaking, and maybe it's a little bit disturbing because there are two people speaking in the same room, but I hope that the sound is good for you. Okay, don't hesitate to chat me or in the global chat if there is any problem, any issue. Okay, so you have an overview of the program that I will show you later. Okay, so welcome. I'm Simon Richir. I'm the Laval Virtual co-founder. It was in '99 and scientific director. I'm also a professor at Arts et Métiers, and we are located in at the Laval Virtual Center, the heart of Laval. Okay, just a few words to introduce that 23rd VRIC Virtual Reality International Conference. So maybe just a little test. If you hear me, please, could you clap your hand? You just use the F4 key on your board. Yes. Some people, yeah, 2, 3. Nice. Go on. Or you can click on your name and you just select clap. Okay. Yes. Good. Thank you. Okay, and it's nice also when you, at the end of a presentation, at the end of a conference, if you can clap your hand, it's better for the conference, for the person who's talking. Okay, so in '99, the first software for augmented reality with a 2D marker appeared in a New Zealand lab. With Mark Bellingers. This application allows to visualize on screen with 6 degrees of freedom virtual objects positioned in space. And on June 6th of the same year, I co-founded the first Laval Virtual International Gathering. It's a long time ago. So 17 years later, no need for markers, no need for a big computer. 50 million people use Pokemon Go and hunt virtual animals with their smartphone all over the world. Today in 2021, immersive technologies, virtual world, artificial intelligence, sensors are 5G also are inviting our daily lives to increase human intelligence. At the Laval Virtual Center here in Laval, Arts et Métiers and Clarté are studying the new uses of immersive technologies, augmented reality, virtual reality, X-reality as we call them. For example, for product design and ideation for Industry 4.0, future industry. Immersive technology are for us amplifiers of intelligence. That's the key word. These technologies will allow everyone to better understand the concepts, physical phenomena, mechanisms, organizations, processes, and immersive technologies will also enable us to understand each other better from a distance, in co-presence with people from different cultures, from different professions, engineers, designers, ergonomists, artists, and also with our collaborators, asynchronous mode, our project team, and with maintenance managers, sales representatives, or even, as in the picture here, with the French Minister of Education. What is the purpose of better understanding and understanding each other better? The idea is to create new products, to create new manufacturing processes, to decide, to choose, to compare options, to compare possibilities, to learn new things, new concepts. So we study representations, embodiment, and interaction in virtual worlds in order to increase human intelligence and facilitate remote collaboration. Then the word for this year is enhance human intelligence. We were during 2 days with Visionary because we organize each year the Laval Virtual Think Tank. Then on Monday, Tuesday, we were with 12 gathering in a castle next to Laval, and we thought about how virtual and augmented reality, how immersive technology will impact society by 2030. And we had a lot of tweets on Twitter, hashtag LV think tank, visionary think tank, and because it was very, very interesting. And one of the key issue was to develop VR for all, and also VR to, or when I say VR, I say XR, I should say XR, to enhance human intelligence. So welcome to a brand new world with XR. Okay, so now few tips before starting the session and starting that today's conference, Virtual Reality International Conference, 2 days in ConVRgence. That is a scientific part of Laval Virtual conferences. So good practice during a talk. Of course, mute your mic, but I think you got the habit of it now. Stay away from the screen. Do not start a dance animation, because the dance animation, you know, is F7K. Is there is some music, and it's disturbing everybody. And take care, because the co-chairs can kick you out of the room, as in Asterix comics. You can be pulverized out of the room. Okay, yes, interesting. You have the full screen key. You know, if you at a time it's not useful for you to see the avatars of other people, then you just click on the small plus at the right up on the screen, and then you can view the presentation in full screen mode. Okay, so good practice for question and answers. You can, if you want to talk directly, you can put on your mic is on, and just ask your question to the presenters, or also you can use the public chat. The public chat is nice, because when you have a question during while listening the speaker, you just write your question in the public chat, and just after that, the co-chair can use that question, can maybe decide the order of the question and so on. But also you can raise your hand and speak directly to the speaker. It's okay. It's also okay. Then you can use also a post-it if you need, if you want. It's not so much used, but okay, why not? You can stick a post-it, not on the screen, please, but just next to the screen, and it's a good option also. You have sometimes, if you want to talk to people privately, you can have some dotted blue circle on the flow, and so you can talk with other people quietly. There is plenty in the Laval Virtual world. You have plenty of that type of blue circle to speak quietly, because now you know I'm speaking, then everybody is listening. It's the same if you put your mic on and you talk to a guy, then everybody will listen to you. Okay. So if you have technical issues, your mic not working, you don't hear the sound and so on, feel free to contact lavalvirtual.com on the website, or even you have here Nicolas and Benjamin here in the room, not far, and they can help you. Sometimes an issue is to go out of the room and come back on the room, and the sound is coming back. Maybe you have to quit the software and come back in the Laval Virtual world, and sometimes the issue is solved. Then okay, don't hesitate to try that. So, and now you can also download for free the proceedings of ConVRgence. It's on the website of International Journal of Virtual Reality that we manage with Olivier Christman and Geoffrey Goris here in Laval. Feel free to share this link, and please help us to make that international journal live and to progress. It's an international journal, completely free. It's diamond access. Then it's free for authors, it's free for readers, and completely free. And then we manage it for you, for the community. Then please help us to have a good quality of paper in that journal. Help us to review the papers. And so, okay, nous comptons sur vous. Okay, Jen, a very big thank to Olivier and Geoffrey, who did amazing work to be able to welcome you today, to review the paper, to prepare the proceedings, to edit the proceedings, and so on, and even that slide that you are looking at today. It's their works, and very congratulations for them. I think you can applaud them if you find the F4 key and to wake up. And okay, Ariette, also the great manager of Laval Virtual, manager of all the conference, and of course all the Laval Virtual Dream Team. Just to add that Laval Virtual team 1 year ago was 20 to 25 people. Now it's 45 people working for Laval Virtual. It's an amazing acceleration because of virtual world, because after the first virtual Laval Virtual, it was such a success, and more 120 events was organized by Laval Virtual in their four virtual worlds, and it's an amazing success. And okay, we are very, very proud of that. So now it's time to start the session one. Will be co-chaired by Olivier and Geoffrey. And so let me introduce the first speaker. I'm just in time, 10:20. And then Anthony, it's a real pleasure to have you in that virtual world, and to have you in Laval Virtual as a keynote speaker. I'm very glad that you accepted. I think you are in England right now. You are not in Laval, but with that Laval Virtual World, you are here with us. Then to introduce, say a little short bio of Anthony. Then Anthony Steed is the head of the Virtual Environment and Computer Graphics Group in the Department of Computer Science at University College of London. He has over 25 years experience in developing effective immersive experiences. While his early work focused on the engineering of displays and software, more recently it has focused on user engagement in collaborative and telepresence scenarios. He received the IEEE VGTC's 2016 Virtual Reality Technical Achievement Awards, and congratulations for that. IEEE VR is one of the greatest conference around the world. Recently, he was visiting researchers at Microsoft Research, Redmond, and an Richir fellow at the Human Interface Technology Laboratory in Christchurch, New Zealand. Then you understand now why it's such a pleasure for me to welcome Anthony Steed. And so, ladies and gentlemen, please applause to welcome Anthony Steed now to our first keynote speaker. Okay, have a good conference. Thank you very much, and thank you, Anthony, to be there. I let you the screen if you want to share your presentation.
Thank you.
Okay, is that okay for you to?
It still says you have control.
Okay, I think you can take control. You just click and you say control. Okay.
It says I'm start presentation, but then it doesn't
Okay.
Yeah,
Did you have it in a PDF format, maybe, to download it, or?
has videos in. I did test it yesterday.
Okay. Or you can share your screen. Do you see the little screen on the
Let me see if
presenter dashboard?
But it still says you have control.
That's right. Okay, try to maybe.
Okay.
Do you find the key to take control?
Yeah, Antonia has control now.
Great. Thank you very much. Great.
Hello. Thank you, Simon, for inviting me. And it's a great pleasure to talk today. As Simon said, we've my lab has been working in virtual reality and mixed reality technologies for over 25 years. And one of the first slides I have is essentially showing you what we were doing back in 1994, 95. And one of the contentions that I'll get started with that may be controversial is that some significant things haven't really changed. So this is the video that was summed up some work we'd done in the early 90s with Mel Slater. I was his PhD student and then his postdoc, looking at things such as locomotion techniques in virtual reality, and also, as you see now, reactions from users, such as fear of falling into a pit. And so this demonstration combines two techniques that our lab is quite well known for. The first one being the virtual treadmill technique, where you monitor the position of the person's head and they walk on the spot and they can move through the environment. Practically my first project as a PhD student, to get that working based on an idea from Mel. And the second one being that this reaction as if this pit is real, which was quite profound and therefore led to us using presence and reaction to things as if they're real as a measure for many years, and to some extent we still do. One of our main focuses or when we look at virtual reality technology is whether the reaction that somebody has is similar to what they would have in the real world or can be modeled on it in an interesting way. And I'll get into some of that later on about what we're using to measure the success of some of these virtual reality systems at the moment. But the contention is that this has not changed that much. I mean, obviously some things have happened, technically speaking. Obviously the technology has of course got a lot smaller and a lot faster and a lot more convenient, and that's a technology trend driven by smartphones for two reasons. One is that the screens started getting a higher resolution and more dense and so on, and that is an iPhone down at the bottom left, but also that is actually also the image generator. So whereas before the system on the previous slide used a custom image generator from a British company called Division that cost 6 figures, this is now a smartphone, complete VR system built on a smartphone that works, that generates experiences that are probably not quite as good as the system from the mid-90s, but certainly getting there. And this system we built in my lab. In fact, I did most of it as a sort of hobby project, being a professor that still likes to build things. And actually that head-mounted display, that is the complete system. It's completely portable. It's battery powered. And that head-mounted display we didn't build, but it's actually a Sony head-mounted display from the late 1990s, which is stereo and 800 by 600. So not too dissimilar from the commercial systems that appeared in the year or two after that. And of course now we have the system, and I'm not shy to say that this is remarkable. what Facebook and Oculus have been able to do for this price point. This system is heads and shoulders above commercial systems that don't cost several times more. It's portable, it's convenient, and it's lightweight, and it's wider field of view probably than the system we had back in 1995. But again, some things haven't changed. So the dominant mode of user interaction is waving your hands around and pulling on buttons. We had controllers, tracked controllers back in the early 90s. The tracking wasn't quite so good, but you could do the same types of things, such as waving your hands, using gestures, and so on. The virtual treadmill is still a problem. That amuses me and some colleagues of mine that have worked on locomotion techniques now for 20 years, that the virtual treadmill keeps getting invented, hopefully these days by undergraduate students rather than experienced researchers. But the idea of using head motion was doable back in the early 90s because it was tracked, and therefore it's certainly doable now with better trackers. So it gets reinvented every so often. Anyway, so the reason for this talk is today is to give you my impressions about what the grand challenges are going forwards. We tend to think of people like me tend to think of virtual reality, or used to think of virtual reality as just improving the technology, just making it better and better, and that would make it more usable. But I think that's a rather narrow view. It is one thing I will talk about, but it's a rather narrow view. And the reason for that is that obviously there are many more things to creating impactful virtual reality than just the technology. And the second thing is that it's not moved that far. So while these screens, these controllers are much better, the form of the user interface is quite similar. And I've argued that with some colleagues in a paper which will be coming out at ISMAR later this year, with a lot of backup from current design practice that goes on in virtual reality. That many of the applications you see now could have been built back in the early 90s. Modulo, the image processors are slightly better, but the types of thing that we're doing now, such as having virtual conferences, playing games, they were all doable back then. And in fact, my first virtual conference where I gave a talk like this, or at least listened to talks like this, was back in 1999 at a conference called Avatars! Where it was done on an online platform that no longer exists. And we obviously, some people have been holding teaching and so on in systems such as Second Life almost as long as Second Life has existed, which I think is over 15 years now. So I'll break the grand challenges into 5 sets. I'll talk about fidelity, which is what the sort of standard, I think, view of what virtual reality needs, which is better displays. But then I'll talk about 4 other areas and give you some examples, usually one from my lab and then one that I think is really inspiring from another lab or another company, which highlight these 4 areas I called self, transparency, social, and tools and platforms. And they'll actually reflect different aspects of our research over the last 25 years, where things have changed on our understanding of what the user interface is. So it's not thinking about devices, but thinking about users. We'll look at transparency, which is a sort of argument about the mixed reality continuum. We'll talk about social and what the technical needs are there. And then finally, if we have time, we'll talk about tools and platforms, because I have a big worry about this field, which is that we're losing control of the means of delivery of applications to users. And it's becoming unnecessarily difficult to create virtual reality experiences for users. Okay, so first of all, I'll talk about fidelity. So fidelity, and sorry, I just have to move a little bit. The most obvious challenge to these technologies is better displays, increased quality. And this is what motivates a lot of the press in the area. So it's what most media reports on. It's the first thing that a magazine or a website will report on, is that this new head-mounted display is higher resolution than that head-mounted display. Now, and it's to some extent the easiest thing to measure. So we can, like we did when we were teenagers, we had fights about games consoles by their power. Now, my lab has head-mounted displays with fields of view up to 180 degrees and pixels per inch of this, and that's going up. And on my desk next to me, I have a very nice display from a company called Varho, which is actually doing some really interesting things in display resolution, where they've got a wide field of view display and then an inset display at very high resolution. And that display is remarkable because when you put it on, you can read text. So you can hold up a normal size piece of A4 paper with 10-point text on, and you can read it, which is one of my tests of the quality. I've been wanting that for about 25 years in my displays. So it's easy to say that here there's been a lot of progress, right? There's displays that are just high resolution. They're going up to 2K by 2K now. The field of view is going up, and there's lots of motivation here in companies building these things. And there's some way to go. So the first two are well understood. The third, the better color, is poorly understood, as is the fourth, which is the better brightness range. So the dynamic range of the display. So we've got a long way to go. There's a lot of development still to do here to create a head-mounted display which shows you high dynamic range imagery, for example, as you might expect from modern televisions that can do very deep blacks and very rich, bright colors. If you look in a modern head-mounted display at low levels, you'll just see the banding artifacts of the grayscale at low light levels, and so there's a long way to go there. And long way to go means an order of magnitude of improvement. So it will need to be 10 times as bright and 10 times at least the dynamic range. And then accommodation, of course, which doesn't make so much difference for me these days because I have middle-aged eyes. But there's a lot of worry and development going on about accommodation. So that your eyes, when they converge, they will adapt to the display. And there are brute force ways of tackling that have been explored and maybe commercialized. And there are more subtle ways using light fields. So just to say that, again, acknowledge that a lot of that research goes on in industry now. To some extent, one of my I don't know how other people feel, that it's quite difficult to work on things such as high quality displays these days. Until very recently we were, and in particular, I had a PhD student, Sebastian Friston, who worked on very high quality, very specific graphics cards. So we basically built our own graphics card for VR, drove a head-mounted display, but that's becoming increasingly hard. They're becoming closed systems, and even just building displays is a little tricky these days because high dynamic range, high pixel displays are actually quite hard electronically to drive. But Facebook Reality Labs has a very large, excellent team working on these issues, and there's a number of prototypes that they've been showing at conferences, VR conferences and optics conferences, and they're really very interesting. The types of thing that could, in principle, be commercialized, built at scale, and sold for consumer prices. So progress is still happening, and we don't work on the hardware of displays so much, but we are working. There's plenty of opportunities to work on how to drive these displays at higher fidelity, and the biggest challenge there The most obvious challenge there is that the displays are getting higher and higher resolution, but graphics cards aren't getting faster at the same pace. So if you're going to drive a 4K head-mounted display, then you're going to need some specialized software because it's too many pixels to do in stereo for a graphics card, at least unless you're willing to spend an enormous amount of money and wait a lot of months to get the latest and greatest NVIDIA card, and also willing to commit a lot of power because the graphics cards are tending towards a kilowatt in power. So this is a piece of work that we showed at SIGGRAPH 2 years ago, which is about how to do a fundamental part of the graphics pipeline called rasterization in a smarter way, which is has been it reduces the number of pixels that you need to draw, essentially. So it devotes more of the graphics card's effort to the place where you're looking, the fovea on the screen, rather than the periphery. And actually, we have a paper that says that follows this up, coming at SIGGRAPH this year, which the preprint is not out yet, but it's been announced on the SIGGRAPH website, where we're trying to use take this further by looking for how to use redundancy in the visual processing, the visual cortex, to reduce the amount of rendering we need to do by exploiting metamerization that goes on in the brain. So not color metamerization, but so metamerization that happens in the V2 region of the cortex, visual cortex. So lots of bandwidth to save there, and that is the focus. You'll have, if you're in the more graphics end of the community, you'll have seen that there's been a lot of focus on trying to improve the overall fidelity of the experience by devoting resources only to those parts of the experience that need the bandwidth, because our displays have now outgrown the capacity of our image generators to generate high quality images at interactive frame rates. But I'm as guilty as many of my colleagues as focusing too much on graphics. And just to say that fidelity is easy to explain for some senses. The audio is relatively well developed, but haptics, smell and taste are very underdeveloped and firmly back in the university realm of building displays and systems that explore this. Haptics is another 20-year challenge in my opinion for virtual reality. The robotics challenges are immense, and we have some work coming out soon which is looking at high dimensional robotics, or at least trying to create systems that generate the tactile impression of being very high dimensional without having a large number of actuators, because actuators cause your system to be complicated and unreactive. And then smell and taste, we didn't work on this for many years, but we are now working on smell and taste to improve the fidelity of those. But again, in an aside, in a link to another interest of mine, which is about sensory fidelity. If you go and talk to the sensory perception people and tell you they're working on virtual reality, then they'll start talking about interoception and other senses which are simply not addressable. So there's a long way to go on the design side to how to improve fidelity, but how do you, some of these on the right, such as blood pressure, are not amenable to stimulation. It's risky, it's just hard, and therefore how do you create a really high fidelity? If you start thinking about it, creating a really high fidelity experience doesn't make a lot of sense to some senses, because you can't create directly the impression of being physically tired. But of course, you can try and induce this, you can try and storytell into this, and therefore I think we'll, in this story of the next 10 years of this field, we'll be engaging a lot more with people that sort of focus on the storytelling and engagement side, because fidelity will stop having returns on investment, or at least it won't have as much return on investment as focusing really on the storytelling and sensory induction and cross-modal stimuli. Okay, some of them, just to point out, some of them are difficult, some of them are dangerous, and many of them are interrelated. And again, most people who've done virtual reality for a while will know this from experience in any sort of commercial experience, any of the commercial systems, that sometimes you do something and occasionally you spot that it's odd. You're looking at a nice, rich environment, you're doing something, and you see an object, you pick it up, and then you suddenly realize it's got no weight, or you didn't touch it correctly. And we bang our heads all this time. And so, to some extent, that's not a fidelity problem at the moment. It may be in 10 years' time, but at the moment, it's a storytelling, game design / experience design problem. Okay, so the challenges here, just to wrap up. We build better displays, but to do that, we need to understand how human senses process information, need to do research on sensory mismatch, dominance, how the brain models discrepancies, and so we need to better model the recipient, which leads directly into the second set of grand challenges, or the second grand challenge. And this is the bit which is probably what you might venture is the science of virtual reality, which is the interaction between the interface of the person, the interface of the system, and the person themselves. If we're going to immerse people, make them feel as if they are there, then of course we need to put them there, not have a head-mounted display and two hand trackers in the right place, but have them feel as if they're there, which means modeling them. And I think most people are aware of this this type of work now on body illusions and the relationship to neuroscience. But I'll give you one example because I think it is actually quite telling, and I think that it emphasizes the need for us to model the person, not because we want to see it, to model the user, not because they want to see it, that is of course very important, but because they use it. So it is the primary resource for them to interact with the real world. And there is a lot of embodied knowledge in how we interact with the real world, and there needs to be embodied knowledge in the virtual world, and that can be quite tricky if you don't think through what that means for somebody who's holding trackers and using buttons. So I will just quickly show you this example. Apologies if you've seen it before. But this is an experiment we ran in 2016 and then updated in 2019. And other people have now reproduced and extended to look at other types of avatar. But this is a very quick run through the experiment. You are supposed to memorize these 8 letters. You're willing to have a try now if you want. It's very hard, don't worry. There's 8, so memorize them. And then do this puzzle. The puzzle is it's all the instructions on the screen. After a few seconds, we ask you to state your answer. You're welcome to shout out now if you're not muted. I think the answer is A and C because I've given a similar talk recently. A and B, rather. Yeah, so the answer is A and B are the rotated versions at the top. And then this is the kicker. Recall the 8 letters. You can text chat me if you like, and I can give you a score on what the 8 letters were, but that's supposed to be hard, right? It's not an easy task, and you can do this with a piece of paper. You can do it with in VR, and you can do it in many different ways, this protocol. So the way that we did it in the first experiment and then updated in the second is that the most obvious way of doing it in virtual reality is that you have a body and you look down, you see your own hands, and you can gesture. So I'll explain why there are 4 conditions later. So you can also do this task with the self avatar. You look down, you see your hands, see your body, but you're not allowed to gesture. So you have to keep your hands on your legs, much like most of you are sitting at the tables in front of me. Okay, you still have to do the puzzles. You don't need to move your hands to solve the puzzles, right? I mean, you can just look and speak to solve it. And then you can do it without an avatar. Okay, so why would you do that? Well, these 2 conditions, if I can find the control to go backwards. Don't think I can. No, I can. Down here. So these 2 conditions mirror an experiment in linguistics on the teaching of mathematics. And what they mirror is that if you do a similar protocol, not exactly the same, but it does involve remembering letters, and you can move your hands, you can remember more letters. Which sounds remarkable, right? So the premise is that if you can move your hands and you have to do a similar task, it's actually factoring quadratic equations, whereas we did mental rotation puzzles. But in their task, the people that could move their hands remembered more letters than people that couldn't move their hands. And in fact, they did this with, I think, high school children and university students. And they had, rather than having them put their hands on their knees, they actually had them sit on their hands. And the explanation from this paper in linguistics is that it emphasizes that gesturing, the movement of the hands, is not incidental to thinking. It is part of the process of thinking about the problem. And in particular, I can't mime this. I don't have a head-mounted display on. But you can imagine that if somebody is in the system and they're doing this puzzle, they could help themselves by rotating their hands in front of their face to do it, or covering up one of the letters to do it. And the same would happen in the original study, that people would use their hands to help them think. And in particular, when they were factoring quadratic equations, they moved around to bracket things. So you can imagine putting using your hands to make brackets in the equation and seeing what happened. And so we'd expect that between here, this condition, and the next condition, that the people in the first condition would actually remember more letters than these. That's the expectation. And the question is, what happens if you don't have an avatar? If you just don't have one, what happens? And the answer to which is that it doesn't matter if you don't have an avatar, you'll remember fewer letters. Okay, so even if you can move your hands, you can't see them, and therefore it is important in this task to be able to gesture and see your own gestures. And if you want to remember a lot of letters, then you need to be able to see your hands and gesture. So I don't think I have a laser pointer for this, but if you the difference here for the paper, which you can, there's more statistics obviously in the paper, is not only is this difference significant, statistically significant, it's also large. So there is a big difference with in the task when you can gesture and you can see yourself gesture. And I think that this result is very important for virtual reality, because it indicates that what you look like is not only other people have done lots of body ownership illusions, they've changed your opinions, been able to change your racial biases and so on. But this is really telling you that your body is a resource for you to use in virtual reality, and therefore you need to get it correct. You need to be able to show it to people so that they can experience it. The follow-up paper asks the obvious question, which is, what should the avatar look like? Does it matter if it be a full body avatar with inverse kinematics? Does it matter that it be a glove floating out in space, not connected to your body? And it seems that it does. It seems that it helps if the body is connected together, so that you can see the connection of your hand to your torso and the rest of your body. So I think the challenge here is to think more about how virtual reality systems capture the user and their body, not just what it looks like, but what they can do with it. So what skills do they have? And that's actually something we're thinking about at the moment. Is I want my VR system to capture the skills I have inside the system. So how do I get the fact into the system that I can use chopsticks or play the piano, or I know how to make chords on a guitar? So this is embodied knowledge I already have, and it should be available to me inside virtual reality without too clunky an experience. And just point out that a lot of this isn't based on making user interaction techniques. It is unconscious. So as I will point out again, just emphasize, when you gesture in that puzzle task, it doesn't help except unconsciously, because the only way to solve the task is to speak. So you give your answer by speaking, but all of the benefit comes from this sort of inadvertent or subconscious or autonomous behavior. And so that work is now being followed up inside neuroscience to figure out what is it about the actions which are important. Okay, so the third challenge is transparency. And so if we've modeled the person, we also need to model their environment around them. And the reason for that is that we use our environment as a resource in our interactions in the real world. So you can't see this, again, because we're in virtual reality, but I've got a Sharpie in my hand and I'm fiddling with it. I hope you can't hear it, because that would be annoying, but it helps me concentrate when I'm talking. And if you see me speak, I gesture a lot when I speak. And to try and keep myself in front of the microphone here at my home office, I've got something in my hands. So I'm using the resource. I have lots of things on my desk, which I could have used instead, but it helps me offload some unconscious behaviors. I'd like to relate that to Milgram's virtuality continuum, which is, I think, a misunderstood paper in our community that talks about virtual reality and augmented reality being as opposite ends of a spectrum. But really, this is a really, really minor part of this paper, if you ask me. And the most important part is actually the extent of world knowledge, which is another scale that is in that paper. So whenever people make an argument to me that augmented reality needs to model the world around us, and therefore will be a quite a different system to the virtual reality, I just argue back, saying that, well, anything you could use in augmented reality, for example, to place information, model doorways, model buildings, track and so on, I can use in virtual reality as well, either for safety reasons or for this purpose of picking up and waving in the air the Sharpie that I have in front of me to use it in virtual reality. So one of the things that we're trying to do at the moment is that if you're sat at a desk and you pick up anything on your desk, it appears in front of you inside the virtual reality, so you can use it. Obviously, for a pen, we'd have to model that it's got ink in it, but for many objects, the use of them is just the manipulation of them. So it is the form of them. And actually, once you've gone down that line of thought, then actually you can use many objects in the real world for you. Now, I'd like to emphasize this by showing one example. And as Simon mentioned, I was at Microsoft Research a couple of years ago, and Jackie Yang was doing this project, which I had the pleasure to try. And it's using, this is I pose this to the students and ask them, is it augmented reality or virtual reality? And have them vote, and half of them say it's augmented reality, half of them say it's virtual reality. So what's happening here, if I go back to the beginning, is that the person is walking through Microsoft Campus, but the campus has been completely transformed into a different place, something that looks like New York. So as you walk across the campus, you experience a different place. And that comes with a lot of caveats these days. It's quite crude, okay, I can't get off. Yeah, okay, right. Okay. So it's quite crude at the moment, but it emphasizes the fact that if you model the real world, so there's definitely an augmented reality component to that because it's modeling the real world and in real time, but it's showing you virtual reality, so you don't see the real world. You could argue it is actually augmented reality. It's something called transformational augmented reality that takes the real world and just changes its appearance. But actually, that demo also plays with that idea because most of the real buildings turn into people. Right, so most of the real obstacles are actually dynamically created crowds that shepherd you away from walking into trash cans or dustbins and so on. So I think this is, again, it is a grand challenge for the field that we're scanning systems. To some extent, you can see that already in that most consumer virtual reality systems use some sort of guardian system, and that's for your own safety, that you don't stand on things. I talk a lot about VR's cat problem, which is that's great, but it needs to happen in real time, because if I've got a guardian system but I have a family cat walk into the experience, I need to be able to not have the virtual reality stop me stepping on the cat. And obviously for cat, you could substitute any thing that can move autonomously, anything from Roombas through to other humans. And I'll give you a simple example here. So what we've done in this experience on this paper is satisfy a particular constraint of a collaborative VR system, that people believe that they're in the same virtual space, but they have different physical spaces. And so this system of merging environments is actually dynamically morphing two real spaces to a virtual space, so that in a subtle way, so that people don't see that the person they're collaborating is actually in a differently configured space. Now, we've really emphasized the difference here, that there is two rooms where you might have different objects in the center that you need to walk around the outside of. So it could be a living room or a conference center. But again, the idea here is that we're using the system to model, the systems model the real world, in this case not to directly transform it, but to the virtual world, but to rectify differences to somebody else's space. So that's another I think interesting use of this notion of reconstruction of the real world. Okay, so leading on to the next challenge then, tools and platforms. So for many of us that worked in the field for a while, that one of the joys of early work was building your own software because people weren't doing it for you. So my postdoc career was writing virtual reality software and and thinking through things like languages, systems, databases, and so on. And to some extent, we've come a long way in that we now have game engines that take a lot of the effort away from us. But I think we're reaching the boundaries of what those game engines are doing. They're not changing fast enough for some of the things that we want to do. So so if you talk to most people about tools, they saw, well, we need better modeling tools to create virtual content, but we also need better tools to allow us to take content, modify it, and do the things that we do in the real world. So one thought experiment I posed to my students this year is, what does the EU's right to repair law mean for virtual reality? So are we just expecting that virtual reality systems work all the time? But if they break, can we fix them? Because there's a direct analogy, I think, which obviously won't be legislated for 10, 20 years. But if we're going to invest time in things like Laval Virtual, that's underneath the Virbela software, eventually I want to modify it, right? I see Simon and his team have control over who can put up posters, but there's not the same fine-grained experience of physical space that we would have in a normal experience, like moving the chairs. I defy you to try and move the chairs around. There's a big button that just puts them all back, changes the layout, but you can't socially distance yourself from somebody else and so on. So I think this is really interesting, because again, if you reflect on the work on embodied cognition and transparency, then you start go through these ideas about modification and what a workshop is, and how we customize, the profound ways we customize the real world in order to make it better suited to us. And that can be from everything from efficiency, having the things near to hand that we want. So in front of me, I have a whiteboard on my left, I have a cork board on my right, and I have my current paper drafts pinned up here, and my Father's Day card. And on the left, I have a list of things to do. And, if I'm going to have a virtual workspace, I want the same things. I don't want somebody to sell them to me, I want to build them. I think this is quite profound, because it's very hard to do. So here's a simple example. Sorry, I'm speeding up a bit because of time. This is one of my most recent graduate, Daniele, has done this system, which again is about tools, but it's about exploring how to find objects in a database. And I think this is a lovely project. You sketch roughly what you want in the system. So I said, you take out a red pen, you sketch the thing that you're imagining, you think is there, and a machine learning system can then find this object in a database, or at least the most approximate object in the database. You see, he just sketches that, presses a button, and it looks in the database for chairs that match. And you can imagine that being a simpler way of accessing certain types of database and being more amenable to then going and sketching and modeling and so on. So I think that's an interesting variant on the issues of tools. Okay, so then the tools for the masses that embed knowledge, simple construction authoring. But how do we repair things? How do we make them in the world? I think is a really crucial thing. And again, it's nice to see some of the social VR platforms that are out there are sort of coming back to tackle this problem. That obviously people that are of a certain age that were building systems back in the early 2000s and so on already had got to grips with it. How do you build, deploy, and then modify these systems? And it's really interesting, I think. So that's a lovely area, I think, for a grand challenge for the field, is how to deal with post-release modification, because Unity won't help you at all. I'm overstating that. It can help you a little bit, but it really needs a new way of thinking about the interaction between assets and code. And finally, I talk about social, because this is the space that we're doing most in at the moment. The grand challenge is to think about not just we need social spaces, but we need to have social rules. We need to be able to build constructs. And again, there's a lot of knowledge about this in as systems such as social media, massive multiplayer online games have talked about over the years. So I think I will skip this experiment because of the interest of time. But just to emphasize that, to link it back to the embodiment, is that people do use their bodies in the virtual world. I have to say the Virbella platform is a little complicated in this respect. But if you have people in a head-mounted display, then if you give them avatars, they start using them in quite remarkable, interesting ways. So this is to cut the long story short, this is a person in an experiment using her avatar as an information blocker. So this is a viewpoint of somebody where the pink avatar is shielding information on the table because this person doesn't want the other person to see what's on the table. And that is a really, really fascinating emergent behavior. And so we are looking at enabling this through a toolkit which we released because we think we released a toolkit called Ubic. We don't have any published papers about it yet, so you'll just have to believe me that it's useful. But where we put together some of our prior experience on building these systems and made it a completely open source under the Apache license, which is open enough you can do whatever you like with. And for those of you who are developers, it's sort of out of the box. You just load it, click play, and you'll be connected to a server that we run, which can support these types of system. And if you're interested, I can tell you a time to come and meet us all in the system, because those are the avatars of most of the developers of the system. Well, it's the people that help with the developers, help develop or have particular requirements that we're iterating on. So we can start to get into building these things. Okay, so I'll wrap up there. To some extent, we have the systems we wanted to buy 30 years ago for less than 1% of the cost. But we are stuck in this paradigm where the focus on head and hand devices, and now I can say that we have a big review paper coming out in ISMAR this year, which is looking at, what are the design issues that have been, highlighted, the limitations of this and some of the opportunities for this paradigm that have come from commercial software. And I think there's lots of scope. I mean, we tend to get the press in particular focuses on the first of these, and sometimes the last, usually to criticize some of our established players in the field. But we can hopefully see that there are other challenges. So my own belief is that the social communication we're going to have the most impact. But I think, and Virbella is a very promising system, and many of the others are really interesting. But I think there's a lot of work to do to improve these systems, make them more amenable, and I'd just like to highlight there's something for everyone in the social and design, the social systems, from language design, decision theory, through to some low-level cognitive, so low-level systems aspects, and even operating systems. So I'm thoroughly convinced that we'll be going back and look. One of the implications of this current expansion of VR will be that we'll go back and look at operating systems again and figure out what we want from our operating systems, and so that we can do a better job of creating virtual reality. Okay, thanks. And I think we've got time for some questions. I don't know what Simon wants to do about that, but and apologies, apparently some of the videos didn't show because it's on Google Slides. But I can possibly post the Google Slides into chat, and you could have a look at some other time. So I'll put that in the private volume chat. Okay. The link if you have missed a video.
Yeah, okay, thank you very much, Anthony. It was very, very, very nice presentation. So we have sometimes for a question, because the next speaker is talking tomorrow, and we have the next speaker is at 10:45. Then we have plenty of time question, but we are not. It's not. We have not to use all that time. That's. But we do what we want. Okay, then maybe if you have question in the audience, because in the audience we were around 30 in the virtual world and around a dozen in the real world, because I can see in the room next to that speaker room that there is people in the convergence room here in real
Simon,
in Laval.
there's a question from Geoffrey in the private chat.
Okay.
Yeah, I can see a couple of questions.
Oh yeah, okay.
Yeah,
Okay,
one
you
from
see.
Nicolas.
Yes,
Voxel
Nicolas.
engines. So do I think voxel engines are sufficient? So the voxel engines, as in Minecraft level, no. Voxels as a representation, at a very fine scale, possibly. It's back to the old graphics questions of what types of you can certainly use voxels to render anything. I think there's some open challenges about how to do physics and simulation in voxel engines. So I'm thinking about, even in the graphics, there are some hard problems like subsurface scattering in voxels and things like that. So if you're wanting very high fidelity, I don't know, but that, of course, you might know from the graphics, they're moving away from these sort of explicit representations to implicit neural representations, which sort of look like voxels, but it's sort of neural basis, which I must admit I haven't actually. I like the pictures of, but I don't understand exactly how they work yet. So I think yes, it could be, but I think there's a long way to go. There's some open questions, partly around the how you will do certain types of simulation with them. So physics simulations, for example. And then Jeffrey sort of asks link between self and social challenges. Yes. That's a fascinating question, and I glazed over it. Sorry, sort of skimmed over it. When I said that the system should model the person, that is to support them interacting with the world. So one of the logical extensions of that experiment I showed is that in the virtual reality, if you wanted to create natural interaction on even those math-like problems, you should probably model the user themselves. You want to know what their maths capability is. You want them to sit a test. Then if you're doing the virtual reality, that's a good test, right? You can get them to sit an SAT or something aptitude test and see if they're the same as in the virtual world as the real world. That is a great experiment for somebody to run. And my hypothesis would be that if they looked more like themselves, they'd probably get a result more like themselves. Now, the next question is, can it be better than themselves? Again, Mel Slater has shown some work where you embody Einstein and you appear to be smarter. I personally don't think that's anything to do with what you look like. I think that's possibly to do with storytelling and suggestion. But I mean, it is an interesting question. Like, do you want to look like yourself, and could you make your own capabilities better, like by changing your body? But you highlight a second aspect, which is, what do I look like to other people, or what do I want to look like to myself if I looked in a mirror or other people looked at me? And the question for there is obviously that people need to be able to decide. So this avatar is the closest you can get to my own hairstyle, and it's one of my tests of social VR systems. Do they have an avatar which is bald on top but not completely bald? Rec Room does, but 99% of them don't. Okay, so I can't have my own hairstyle in this for some reason, and I like to look like a cartoon of myself in these systems. So that highlights that yes, there is a tension there, and people may or may not want to look like themselves. In this social situation, I want to be a caricature of myself, but in other situations, I want to role play, or I might want to change my appearance and create a character that I engage with this community in. Okay, so yeah, I think that's a fascinating question, and yes, I think the tools need to be there for people to decide, along with the education about the security and the social implications of that. Because I think one of the challenges we haven't yet addressed is, if you can dress up to be anything and people do role play a lot, then obviously it may or may not make certain types of social relationship easier or harder to form. And you can just look to the games community for that. Obviously, there are very rich, very profound, life-changingly positive relationships coming out of gaming that you hear, but you also hear about the sheer amount of misogyny and racism that goes on as well. So obviously, there's a fine line to explore there about how people should be encouraged to represent to each other in order to facilitate rich and positive communications. Yeah. Okay.
Yeah, I think Trevor raising hand. No.
Yeah,
Shane,
yeah. I think I've
Yeah, Trevor.
got the
it's to you.
microphone on.
Yeah.
So thanks, Anthony, for the presentation. It was really good. Just to add to something you said at the beginning, you mentioned that a lot hasn't changed in VR. Of course, things have got cheaper and better resolution and so on. I think I can say about something that's changed in the applied setting. So I work in VR in industry. My company is ESI, and it's mainly used for well, they do a lot of assembly simulation. So if you're working in the automotive industry or in the aviation industry, assembling a car or plane, you can simulate that first. One of the changes I've seen is a massive increase in the use of HMDs. So a lot of the work was done in caves before, simply because the industry has the money and they can build very, very high resolution caves. But they're starting to realize that, well, I think one of the issues is a lot of their colleagues are distributed, different offices in different countries, and they're starting to realize, well, hold on a minute, why can't I just pick up a HMD and join you guys? And you guys are in your cave, or you're also in a HMD, and I'm, might be from the US to China, or Japan to Thailand, and so on. That's where our customers work. And this was, I think, increasing even further with the pandemic. So a lot of people couldn't go to the office, couldn't use the cave, and started to say, well, hold on a minute, why don't I just buy a HMD and put that in my home office? So I'll say that's just to add to what you said, from the applied perspective, there's a change that I've noticed there.
Yeah, thanks, Trevor. It's yeah, I was being a bit cheeky by saying not much has changed. It's just a challenge to think through that could have the applications you had now have been developed back in the 90s. We want to know a few things. Obviously, the graphics is better. So in industry, one of the main challenges is the amount of time that you can spend taking source models to put them in virtual reality, because we still have constraints there. We've always had them, and we probably always will. That there is a big difference between what you can get on a CAD workstation to reasonable frame rate and what you can get inside a real-time stereo immersive system. There's an order of magnitude there, at least. But yeah, I think that the accessibility is great. There have been brief periods where head-mounted displays have got into the hands of games designers in the past, and we've seen some very creative content. But I've no hesitation in saying that, yeah, I mean, this thing that we're going to present at ISMAR goes through some of the really fascinating things that have been done in modern applications, and basically just puts a hands up and say, look, this, there's too much success, too many interesting examples out there for anybody to really have a handle on what's the best practice in virtual reality at the moment. For example, for picking up objects or locomotion. So yeah, there's lots of great examples out there. And one of the examples we use, for example, is an industrial example from Audi, when they were trying to show off a car. But they have a lovely locomotion technique, which only works if you're walking around the outside of a car, say, shaped the same size as the particular model of Audi that they're working on, because it's very heavily designed for that specific situation. So as you walk around the car, they sort of do something that which people in the field would recognize as 7-league boots, but it's constrained to be around the outside of the car. Anyway, so I think there is a lot has changed. Yeah, the main thing that has changed is there are millions of people with these things now, not thousands.
Yeah, I agree. Yeah, thanks.
And also, again, I'll say something very positive about game engines. Game engines have made it possible for any game developer to make something, and that has led when we started this review of, and also there's a recent paper at Kai, just listing all the locomotion techniques that have come up with, and and he's got to reinvent. One of the reasons I mentioned the virtual treadmill is because one of the things, the papers they list is another reinvention of the virtual treadmill from roughly 2016. There's just too much going on. There's too many locomotion techniques. I think this paper from Margosoli's and colleagues has around 300, 200. It's definitely three figures. The number of locomotion techniques, and that there are hundreds out there. Sorry, Simon, what should we take next?
Great. You have also a question of Pascal. Are there ideas of brain control devices?
Yes. Yeah. So we can definitely. I mean, people have worked. We've done work on brain-computer interfaces in our cave system about 10 years ago, and we have brain-controlled locomotion technique, and also some brain-assisted selection techniques. There's a long way to go on those because they're very low bandwidth at the moment, and actually, some people believe we can discuss this outside, possibly away from the because it will take a long time. Some people believe in this sort of plug in your brain, neural interface that will have. That will, you'll just plug in somewhere in the spine and CVR and so on. It may be possible. I think there's good reasons to believe that it's not possible, and that's the body. In that you move the body to do things, and that is one of my challenges to people that think that is to look at this experiment with the gesturing and the puzzles and say, well, how do you actually do that in a brain-computer interface? You'd have to model the body, so you'd have to have the body there anyway, because the person's, you need to measure the size of the hand, for example. You need to know what the body state is, because that's what the body will that's what the brain will model. It's what it's good at is understanding and predicting what's going to happen with action. So if you're going to plug in, you're going to have a neural interface, you're going to have to understand that loop anyway, which to me sounds like a very difficult process of modeling the body as it is now. Maybe you can get away with a body you scanned a month ago, 2 months ago, a year ago, but if you learn a new physical skill, then what is it that you've changed? You've changed the brain and the body. So yes, I think they are useful. There are some obviously very profound implications. The locomotion technique we did in the cave was for somebody who had tetraplegia, and it was a sort of virtual wheelchair experience, because the goal of the person that we had was to control a real wheelchair with the brain-computer interface. So it wasn't a straightforward, we're doing it because we're interested in VR. We were doing it because the person had been training to use that particular BCI, brain-computer interface, for several weeks, possibly months training already. So they put in dozens of hours, I believe, into the training to make it work before coming to us and then seeing if it worked in virtual reality. So there's a lot of promise, but I think certain people who go on Twitter and talk about how this is all arriving about as fast as their self-driving cars are actually overemphasizing what's going on in that field. There are, a lot of what you're seeing is actually, won't be very customer friendly. Let's put it that way.
Okay,
Yeah.
There's another question, from Antoine.
Yeah, okay, it's about impact of avatar and memorization.
Yeah.
Yes, so Antoine asked you talked about the impact of avatar and memorization, and it seems that having an avatar allows you to memorize. So actually, I'll just point out that although the measure is memorization, the actual hypothesis is that the gesture helps with the spatial rotation task, because you can mimic the rotation with your hands, and that helps people do that. There's an easy analogy, which is some people rotate maps to help them think about routes, and other people don't. So gestures for rotation is something that we might understand quite a lot about, or our brain might understand quite a lot about. So the memorization task is a side effect. So it's the puzzle solving impacts your short-term memory. So I think the way to go with that is looking more at the performance of the person. We're in particular interested in hand gestures at the moment. So can you do something similar with finger gestures? That might not make so much difference in England. We don't have a rich culture of hand gestures, but it could make thinking through stereotypes, it might make more more impact, in south of Europe, where language is more there's more gesticulation in language. So I think yes, we can look more at the body, and there are lots of things wrong with that experiment. Lots and lots of things wrong with it. The paper's quite honest. It didn't look much like them. We only had 2 avatars, and so other people have looked at the impact of having your own hands in there, and I think to build a better science around this is looking at other impacts, or trying to find other effects of the avatar would be another great way forward. So other tasks where the gesture appears, the ability to gesture with an avatar, or the form of the avatar interferes with a task. We have tried with physical manipulation puzzles, but the problem with that is that virtual reality is not very good at physical manipulation. Picking things up with a controller is quite unrewarding, because you don't get to use your embodied knowledge about grasp and so on. That is a grand challenge for the field, is solving the handedness problem. So what we're going to look at is gestures with the hand. So finger gestures and being able to highlight text with a finger, things like that. So we have to point with a finger on whether or not that impacts on your ability on your cognitive ability, or interferes with some other task that you're doing. Can't say we're running that. It's just something that we're thinking through at the moment. I'm happy to collaborate with anybody that has a resource to work on that in the near future.
Yeah, so very interesting. Maybe a question. I think. Yes, there's Oliver. Okay, Olivier. What are the challenges of representing people's emotion in social workspaces?
Yes, excellent question. So a couple of recent head-mounted displays that are tracking facial expressions. So the new HP Omnicept, and I've got beside me one of the cameras you can attach to a Vive to track facial expressions, and there are papers on reconstructing facial expression. So I think things can be done here. They certainly impact communication. Whether or not they improve it is a definition of your goals. So I think that is a resource which will become available in the next couple of years, at least in some degree. But it's something that we need a lot of community thought around. Is it desirable, and the security implications of that? I think that I haven't mentioned that at all in the talk, but I we do worry about it. If the VR system is tracking has cameras pointing at your face, and it has an enormous resource for tracking your reaction to adverts and similar media. And there isn't a well foregrounded or well exposed social negotiation about trading there. So what do I get back in response? And again, that's a discussion to have outside the room, probably, because there's a lot of controversy around one particular manufacturer's investment in this field, which I think is wonderful, but obviously it's a company, so they have to make a return eventually. So yes, it's not necessary for better communication. I should point out again that another angle to your angle of the answer would be that we have great communication in VR with people we know well. So I spend part of Friday afternoon usually in UBIC itself or Rec Room with my postdocs and students, and we sit around and we have a chat, and occasionally we shoot each other in Laser Quest. But it's great communication, right? I mean, it possibly the availability of Laser Quest at short notice, instant notice, is probably better than some ways superior to the real world. But no, we haven't studied. The one thing I can't do is compare the social witness, the coherence of that group, their effectiveness, in an alternative mode. But my gut feeling is that that is working well for people who know each other well. But meeting people, I think, is a novel communication. Meeting people, I think, is badly supported at the moment. And yes, the emotions and better support for emoting than pressing F4, which is at least it's available. But better social systems will emerge, I think.
Yeah, because our avatar right now in the Laval Virtual world are not so emotionally responsive.
I have to say, I prefer presenting in here than the auditorium because there's me turning backwards and forwards. Does mean that at least I'm animated. Whereas in the auditorium, there can be a temptation to just face the audience because you get a separate view of the slides. So I think this one actually feel more like a meeting than speaking in the auditorium in Verbella.
Yeah, and I've got another question. Do you think XR and associated technologies, of the technology, artificial intelligence and so actuators and so on, is that all that technologies could lead to user extreme cognition, enhance user at a top level, enhance cognition. I feel everything.
Yeah, so that's a really interesting question. So my reaction to that is a little bit conservative, which is that people enhance their cognition in the real world by modifying it. Right. So I already talked a little bit about this, that I think the virtual world should be more malleable. So I talked about, you already know a lot about my desk. I fiddle with pens. I've got 2 notice boards in front of me and so on. So I think enhancing, XR can enhance cognition by making tools available to you, but of course tools, you have to get used to the tools. So I think there's not automatically, but I think we can build better tools by in XR to make them more available. But I think the analogy would have to be, what tools can you build in the real world, and making simpler, more fancy, possibly more powerful analogies in the real world. Certainly, we can do certain things quite easily if you think about the augmented reality end of the spectrum of presenting the right information to people to make a decision. That's a sort of given that we can get information in the right places, but we also need tools in the right places because we use tools to do cognition in the real world.
Okay, and maybe if there is no other question in the chat, maybe I can ask a last question. Maybe you talk about tools for the masses, but which would be the killer app? What would be the killer app, and which would be the company? You told Unity was maybe not the good one. Would it be Snapchat, Instagram, Facebook, and for the tools for the masses?
So what's the best tool for the masses? It's a shop. So how do we modify the real world? We bring things into it and arrange it, and then people like me, we make things, do DIY furniture and so on. So I think the killer app is really a system that doesn't exist yet, that allows me to create places and share them and inhabit them and use them. So, and the person that will make most out of that is the people that can sell things into it, and the artisans, engineers, artists that will make things for it. I think Second Life got a lot of things right. It was just too early, and it's a bit, and it shows its age a little bit, but it supported people selling things within the community. And I think that getting to that point where you have a system that allows you to own things and reliably own them and move them and repurpose them. So that's part of the underlying thing I think about the platform. So we don't have one of those yet. I've got every social VR account I've got has a different, some of them have virtual currencies in them. Some of them means I can buy things to make my avatar look special. I personally have no interest in doing any of that because I can use them for an hour a week, and I can't transport them anywhere. So hopefully that there will be a community. More and more people will realize this, and we can possibly come up with some standards for how to extend that. And people say that that's just going to be based on web standards, and I think there are, again, it's an outside discussion, but there are really important things that web standards don't do, such as personalized avatars and ownership of objects and lifetime control of things, which just don't have analogous concepts.
Yeah,
The analogous concepts on the web just don't have the same power, and they don't have the same role.
Yes, very interesting. That it could be a tool inside a tool that remind me some video games as Age of Empire, for example, or so on. Then we could reach a twin world, maybe to start a new life. Okay.
Yes. So if I think about the house analogy, there are many things in here which I've just bought, but there's lots of things I've modified. So I've bought them and I've changed them. And how do I do that? I mean, I can't. How do I? I'm sitting at a desk that I made, right? So that was quite a profound change from lumps of wood into a functional desk. But there isn't an analogy for that. There are woodworking experiences, but how do I make my own desk to use in a private office in Virbella? It's just a question that engineers can say how they can do it, right? A good engineer will tell you how the system could do it, but nobody can say how it's going to interoperate across everybody's social VR systems.
Yeah, I agree. Okay, Anthony, we had you an hour and a half. I was very glad to be able to discuss with you, thanks to the Laval Virtual World. I think we can applause again if you can find your F4K. Yes, okay. You have multiple possibility in lot of possibilities in the virtual world. You just yes, press F4 and but you can also type /help in the public chat, and you will see a lot of tricks, a lot of hidden key. Okay, so Anthony, it was a very nice moment. I think we enjoyed it a lot, and I thank you again to have answer yes to my invitation, and so I was very glad to have you today. Okay, I think in 5 minutes we will have you your next speaker, and so okay, it's just time to have a short break in the real time maybe, and in 5 minutes we gather here again for the next speaker. Anthony, thank you again. How is the weather in London? You're still in London?
Cloudy, but at least not raining.
Okay, yes, it's a strange weather for July. It's the same,
yes.
The same in France and Laval. Okay, thank you again, and meet you soon in the real world.
Bonjour Nicolas.
Ouais, alors, je sais pas si tout le monde va m'entendre là.
Ouais, moi j'entends, c'est parfait. Donc,
ok.
Merci beaucoup d'être là déjà. Et puis, je pense que vous pouvez vous préparer sur l'écran tranquillement. Et puis on va commencer à 45.
Super, je vais faire ça. Je vais voir si je peux prendre le contrôle. J'ai vu qu'il y a une version, mais j'ai fait quelques petits changements. Bon, juste corriger le net, quoi. Je vais voir si je peux prendre le contrôle.
Ouais, donc là, j'ai remis le programme. Olivier, Geoffrey, si vous pouvez, toi, là, ce que j'ai mis sur l'écran, je crois que vous pouvez le mettre avec la petite étoile, le garder. Ça, vous pouvez le rafficher facilement. Vous voyez ce que je veux dire dans le tool présentateur, dans les outils du présentateur.
Ah oui, d'accord.
Okay. Toi, tu
cliques. Je viens d'enregistrer le lien. Voilà, je remettrai après la présentation.
Voilà,
bonjour
ça,
Nicolas.
on peut l'utiliser pendant les 2 jours tranquille, quoi.
Okay.
Bonjour Nicolas, je suis à disposition, je vais les mettre en favori au cas où aussi, hein. D'accord?
Ok, ouais, ça marche. C'est Nicolas et Benjamin. On est
voilà, Benjamin et Nicolas.
Hop.
Mais merci Simon, oui, j'avais zappé qu'en fait il y avait un trou. Hein.
Non, non, mais pas de problème. Là, on a c'est bien, ça nous a donné beaucoup de temps pour échanger avec Anthony, donc c'est super, quoi.
Ouais.
Et j'ai le contrôle, donc super.
C'est bon.
Good.
Pour
You
toi,
got the
Nicolas.
control.
Got the control. Ok, j'ai des liens à mettre dans le public, dans le chat.
Regarde juste. Ouais, c'est bon. Moi aussi. Ok. Ouais.
Alors je vais expliquer avant de commencer ce que sont ces liens.
Oui.
Il y a une main levée, oui. Si Samuel m'entend.
Oui, c'était un essai.
Ok, ça marche.
J'apprends à utiliser l'environnement.
You do not hear me. No. You. We don't hear you. Roy. Bon, alors du coup, je sais pas si on attend Simon revienne. Je vais aller le voir. Il bouge.
Simon est encore en away, donc je sais pas.
No, it's not a problem. Maybe you can begin because it's time to present this paper. So thank you, Nicolas, to be here to present your paper. So you have a slot of 30 minutes, maybe for 20 minutes of presentation and 10 minutes of question and answers, if it's okay for you.
I've prepared 20 minutes of presentation, but I will go at my own rhythm. It's cool.
Okay, that's perfect. Let's go.
Hi all, I'm Nicolas Ribeiro. I'm a doctor in neuropsychology, and I'm going to talk about how VR technology can, to our opinion, offer important new information in cognitive assessment. And we have made some study to back up this proposition, a study that I will present. So to begin with, I would like to thank the committee for having accepted this paper. Please don't touch the for having accepted this paper and presentation, because I very much appreciate this event and how it is both very scientific and both dedicated to the general public. So it is a real pleasure. I would like also to thank my colleague Toinon Vigier and Yannick Prier for having participated in the aforementioned study. And I would like to thank the LS2N laboratory in which I perform a postdoctoral task currently. So thanks to all of them. So I'm here to talk about VR and cognitive assessment. And I would like to start this presentation with some numbers. There is 150,000 head trauma per year. There is also more than 1 million people affected by Alzheimer's disease and other neurodegenerative disease currently. And there is a stroke every 4 minutes. And all of that is just for France. So for all these people, there is a need to assess cognition, to identify the impairment that comes with those events, and to identify what can be done to facilitate these individuals' life when such an event happened. So to do that, we always need the best tools we can get, and VR is probably the best tool we can get now. So the take-home message for this presentation will be that virtual reality should radically change the way we think about cognitive assessment, and is an important resource for this assessment. Alors j'ai perdu. Sorry, just a sec. Okay. So I will talk initially about what a psychologist do, and especially a neuropsychologist do, and I will present some general views on cognition. So I've already said that, but I'm a neuropsychologist, and neuropsychology is fundamentally a discipline that bridges neuroscience and psychology. And to answer the question of what is neuropsychology, I am taking the shortcut to just talk about what does a neuropsychologist do. And there are multiple reasons that can make a person one day starting to function in a way that make his or her adaptation to the world weak or fragile. And the neuropsychologist is the individual, the person who comes to understand how this individual function and how he, and help him to identify what can be done to help him or her to be adapted again. And in order to do this, it is necessary to know the mechanism that allow individual to function, to be present in the world. And before presenting the study that I am here to present and that we have carried out, I must relay information about who we are in this world and how we are part of it. And I'm going to start with a proposal. We are our nervous system. We are made up of billions of cells that activates when we come into contact with the world. And I know this is a fairly obvious way of putting it, a fairly obvious proposition. And to say that we are only our nervous system is, for the least, an incomplete truth. So we need a better approach that could serve our meaning. So this approach is that we can say that our system continually tries to react to the world in order to maintain homeostasis, equilibrium with the world. And to this homeostasis, to this equilibrium, it relies every time on its previous and past experience with the world. So the purpose of our nervous system is to enable an coupling with the world, an intertwinement that allow us to function, and this is that generate cognition. So the corollary of this proposition is that our system is always trying to make sense of the world, depending on what comes from the world to it. And we can actually play with this system. So you have in front of you an illusion, a quite known illusion. This is the spinning dancer illusion, and this is a bistable picture. And you can see this picture in two ways. Your brain can interpret, make emerge a sense of this picture in two ways. In one way, the leg is in front of the picture, and in the other way, the leg is in the back of the picture. And maybe most of you have made the two possibilities already emerge. But if I feed your system, if I give new information to it, new experience, you will see that it is no more easier to see the picture in the center as being in front, facing the camera. But I can also change the experience, and you will see that it is now easier to see the middle image as it's being backward to the camera. So you can eventually play with your own brain by focusing on the right or the left picture, and then switching back to the center picture. And you will see that the more you feed your system with an experience that will suggest that the picture is in a way or is in the other way, you will be able to control how you perceive the center picture. For those who want to go with the animated version of this, you can click on the presentation link I've made in the chat. I suggest you to click on this link after the whole presentation, but you will see that with the animated version, it is even easier to do that. And the more we complicated the signal, the more it is easier to interpret, change the interpretation. So once again, this means that we interpret our life experience depending on the past experience with the world. And if we take a broad view about it, what is the world if it's not a world that is complex in terms of spatiality and temporality? So the problem is that currently, if you ever have a car accident, a vascular accident, and so on, you will be presented tests that are a paper pencil test or a 2D test on computer that can be considered far remote from the complexity of the world. But there is good news. VR technology tries to emulate this complexity of the world, especially in terms of spatiality and temporality. So my proposition is that VR tech will soon be valuable tools that will use in clinical context. And I guess in the 10 years to come, VR or augmented reality tools, if they stay as cheaper as they are now, will be included in our consultation. So I'm gonna present a task that we made to back up this proposition. This is a preliminary study that only serves as the first step in this scope. So there are many ways of questioning how the system works, and one of these ways is the flunker task. The flunker task is a classical cognitive task that evaluates how conflictuous information has an impact on the quality of information processing or emergence. So in other words, when you have two informations that compete one to another, your brain processes both at the same time, and there is a conflict that must be resolved to allow the emergence of behavior. This is not a sequential step, but more than a thing that happens simultaneously in the same time. Okay, so the fact that we have a cognitive control over interfering information, conflictuous information came to the scope of executive functioning. Executive functioning has many definitions. It is a part of cognition, and it is the ability to select, plan, initiate, and control behaviors according to a set of goals. So there is many definitions. Another one is that executive functioning is an higher order cognitive processes involved in goal-oriented behavior, such as planning and sequencing. So we go back to the flunker task now. What is the flunker task? Essentially, the flunker task presents a signal that can be or not conflictuous, where there is a central character. The central character is the important character, and the participant must focus on this central character and has to press a button depending on the direction that is indicated by this central character. And this central character have flunkers, have characters that come with it, that we call flunkers. And this flunker can be in the same direction or can be in the opposite direction and create a conflict, an interference. So if you are presented this signal, you must press a key with your left hand because the center character is pointing toward the left. So you will have the possibility to test yourself. I will say that just after, but this task and the many iterations of this task have shown a great propensity to reveal cognitive functioning. So, for instance, the performance for alcoholic consumption and Korsakoff syndrome appears with the flunker task. The flunker task also is propose typical performance for Huntington disease and for any neurodegenerative disease that will atrophy the attentional network in our brain. So interestingly, this task also for the major, the typical Alzheimer disease will not exhibit difference compared to the general population. So there is really specificity on this task. And to conclude, this task with Parkinson disease will show a very singular, typical, specific pattern where the responses are given more quickly and with more error. So the flunker task is a reliable task that provide two main indicators and that have been tested and used for the last 50 years. These two indicators are the errors on the signal processing and the length, the duration needed to perform a response, a behavior. So you will have the opportunity to test it by yourself because I've made a version of this task available through this link. It can be done with your smartphone or with your computer, and it will give you some insight about how you function cognitively speaking. You will be presented one of these 6 possibilities, and you will have to answer depending on the central character. So here's my result, and I was quite happy because my results are really typical, really conform to what one can be expect when performing this task. So as you can see, just beside the dog, I've made 5 errors on incongruent trial, while I've made no error at all in processing congruence trial. So what does it mean? It means that incongruent trial are more difficult to process and can lead to incorrect behavior. So as you may see in the right figure, it seems that I took more time to respond when facing an incongruent signal than when facing a congruent signal. And any flunker task should exhibit at least one of these 2 classical results. So you will be able to test it by yourself if you want. So the question we asked to ourselves is it possible to develop a task that relies on a larger, more ecological, natural, situated, and that relies also on more spontaneous movement? And of course, I'm here to talk about our iteration of the flunker task in the VR space, the VR environment. And you can also click after the presentation by clicking the link in chat, where you will see that the task we made can be also applied to a wide variety of individuals. Here, it's my grandfather who tried this task, and to be clear, my grandfather don't have at home a computer, but you will see that if you click the link in chat. My grandfather made some VR task with quite facility. So what is the difference between the 2D task and the VR task, flunker task? Well, one could argue that the most important thing is that in VR we can decompose the movement, because tracking one's computer controller movement in the VR space is what the VR headset do, and quite a few times a second, at least 60 times a second. And when we decompose the movement, we've seen that there is at least 2 types of movement that we can make when facing a signal. So we plotted signal. And we see that we don't see anything. Okay, we are gonna switch to the odd link. Okay, so just we cross our fingers. I guess it is a network compatibility. Okay, yes. So there is two main possibilities. The one is a straightforward trials where the individual push the button with one hand and the other hand don't move at all. So we are gonna talk about the green hand here as the ipsilateral hand because it is the hand that ultimately push the button. And we'll talk about the red hand as the contralateral hand because this is the hand that do not push the button ultimately. So one type of pushing looks like that, and the other type of pushing kinda looks like that. So as you can see, the contralateral end moved a bit, and then the ipsilateral end finished the move. So if we look at these traces, they looked different one to another, and we can plot the movement in ordinate and the time in abscissa for left and right flankers, so when the signal is pointing toward left or right, and for the ipsilateral end, the end that pushed the button, and for the contralateral end, the ends that do not push ultimately the button. And we can see two things with this graph. We can see that incongruent cognition, incongruent signal takes more time to be initiated because they are in red, and we see the red comes in the right side of the curve. And we see that the end that did not push the button, the contralateral end, show more movement of red condition than in green condition. So we made some statistical tests about this discovery, and we've seen that indeed the contralateral end move more when the signal is complicated, incongruent, and conflictuous. The end move more for 6 out of 7 participants in this preliminary study. Which means, and it is quite a novelty to show that in VR, it means that individuals can correct themselves after initiating an incorrect behavior. And this seems to be important. You can probably remember many times in your life where you initiated a behavior and stop it before it's being too late. Starting sentences that could be harmful to another, starting to crosswalk and looking at the red signal and stopping your behavior. If you don't are able to stop your behavior, you make yourself at risk to be harmed. So this is important in terms of cognitive control, to be able to stop a behavior that was initially incorrect. So this is possible, and we see that this is possible to show that using a VR task. And to almost conclude, the classical duration difference that we see with the 2D task, we also see it with this VR task. So in other words, we don't lose information. We just have more information when we place the individual in a specialized world, a more complicated world. So this is almost the conclusion. This is less important than the other thing, but we plotted this graph to know how many trials, how many signal I have to present to my participant to show there is a difference between the processing of complicated or not complicated, so incongruent or congruent signal. And I think that 125 signal is enough to show a statistical difference. And we propose at least 200 trials in our research. So it means that 5 minutes is enough to show this difference. And 5 minutes is really, really a short time compared to a paper pencil test that we use usually to test these aspect of cognition. So to conclude, VR offers new insight into how we function in a specialized situation. This comes with a benefit to the patient, and VR enhances conceptual ecological validity of cognitive testing because it places the individual in a specialized world. And the other side of the coin is that cognitive control continues after the initial appearance of motor responses, and an initially incorrect behavior can be corrected over time. So this offers new insight for the theory and indicators that inform about the cognitive processing. Thank you for your attention. I am available if you have any question. We right now or by email, and we are open to any collaboration. The APK will be freely given on a simple request. Thank you.
Well, thank you, Nicolas. If you have some questions, maybe you can write them in the chat because it's more convenient. And we have few minutes because we have to end at 12:15. So we have few minutes.
And if you don't want to ask me question, you can still try this task to see for yourself. You have this cost on your cognitive processing.
So Nicolas, you show us a test that you adapt in VR, and what kind of other test do you plan to adapt in the next future to try to assess if it's okay to use them in VR?
I guess there is actually already a quite range of use in VR tech to assess cognitive functioning in the scientific literature, but not quite yet to the clinical use. And I guess that one option could be to select the more defining the more precise tools from the scientific literature and tries to adapt them. So it could be anything that we use. We usually evaluate in neuropsychological consultation memory, executive function, and instrumental function to have a picture of one functioning. So any tests, to my opinion, can be used. Maybe there is so this is I have already, to my opinion, answered this question, but maybe there is just a bit risk. To my opinion, what we call the anamnese, so the fact to be in contact with the individual should stay for now in the real world. The discussions that come before the testing, to my opinion, should stay in the real world, while all the tests we perform should be, in my opinion, proposed in VR. As an example, we have a test that is called the Wisconsin card sorting test, where we ask the patient to organize different cards depending on color, depending on form, and so on, and numbers. And once again, it's organizing cards, but it do not reflect how one individual function in his kitchen, for example, or how he drive a car. So if also just the side responses to your question is that if I guess we need to elaborate new tests, but an additional guideline could be to be the closer possible to ecological situation. It means usual situation. Here, with this the task we've made, you never press button depending on the signal across the street. So this is probably not the best idea we've got, and being ecological would be a better idea.
Yes, thank you.
Thanks for your question.
And I have another question, a short question. So you show that you can use this kind of task in VR, but it is enough to use it in a clinical context. Do you need to have more participants for the study to assess that okay, the task is can be used in a clinical context?
Yes, in fact, it is a long way to go to be used in clinical tasks. One thing is that any task should be able to exhibit truly the functioning of patient, and not only here. This was 7 participants that had not any pathology. So one must elaborate the discriminant validity of a task. So more participants are needed, different group, and so on. And I guess this proposition and this task only served as a first step to consider that tracking movement could be another dimension, and that showing a 3D space is a way to give a more complex city than the four wall of the consultation that is far remote from the real world situation. So yes, this is a long road, and there is a need for precise evaluation of metrics capacity of those tasks.
Okay, thanks a lot. So if there are no more questions, maybe we can stop now, and thank you a lot for your presentation. You put your email on the slide, so if other questions, you can directly send an email to Nicolas. And for the next session, it will be at 3 p.m. So let's meet at 3 p.m. for the 2 panels on education, on training, and architecture, and a poster session. So have a good lunch, and see you at 3 p.m.
Thank you, Olivier. Bye.
Simon, oui, Simon, j'avais une question.
Allô? Oui,
Oui,
ça y est, c'est
Simon,
bon, j'ai remis le
oui.
micro. Oui.
Pendant la présentation, à diverses reprises, j'ai dû remettre les sièges. C'est toi qui changeais les sièges ou c'est
Ah
des...
non, non, c'est pas moi,
Alors,
je
je
crois
sais
que
pas
c'est
ce
des
qui se passe.
participants.
C'est les participants qui peuvent changer les sièges. Ah
J'ai
oui, alors
l'impression qu'ils
ça,
ont
il
des
faut que...
privilèges, ouais, parce que ça change tout le temps, et c'est vrai que c'est super
Ouais.
pénible.
Alors du coup, je les remettais, mais ça, il faut que je le signale parce que c'est pas normal. Ok.
Mais
Et
sont
les
tous
slides aussi étaient changés par les slides aussi étaient changés par les participants, je pense.
Les slides aussi, d'accord.
Ah,
Ouais,
on peut
j'ai dû
cliquer
venir
partout.
plein de fois en arrière.
D'accord. Bon, bah ok, bah, je vais le signaler tout ça. Ok, merci Nicolas.
Merci
Bonne journée à
beaucoup.
tous.
Bonne
Et
journée.
bonne pause déjeuner.
Ok, ok.
Merci. Tout à l'heure.
Discord,
Olivier, tu veux qu'on parle dans une salle